Hi, in this video, I will be showing you problem number 3 of chapter 16, section 2. Evaluate the line integral where c is the given curve. Integral over c, x times y to the power 4 ds, where c is the right half of the circle, x square plus y square equal to 16. So we are evaluating the line integral, and c is given to be the right half of the circle x square plus y square equal to 16. Before we get to the problem, what is the line integral for a scalar function f? So the integrand is a scalar function. X y to the power 4 is a scalar function. So now let's see what line integral formula is for a scalar function. So how do you evaluate such an integral? Integral over c f of xy ds equal to integral f of x of t, y of t. That means we are changing the curve to parametric form. X as a function of t, y as a function of t. ds, which is the length of the curve which we did earlier, which is square root of dx by dt the whole square plus dy by dt the whole square dt, where c is a smooth space curve and t lies between a and b. So the integral is evaluated between a and b. Extending this to three-dimensional f of x, y, z for three-variable function. So integral over c f of x, y, z ds would be integral a to b f of x of t, y of t, z of t, and then the arc length, which is square root of dx by dt the whole square plus dy by dt the whole square plus dz by dt the whole square times dt. Observe that the above line integrals can be written in the vector notation in a simpler way as follows. If you write this in simpler way of in the vector notation, integral over c f of x y ds can be written as this x comma y can be written as r of t. So it is integral a to b f of r of t, vector function r of t, times ds, which is the length of the arc, is absolute r prime t dt. So when the special case, for the special case f of x, y, z equal to 1, we get integral over c ds. So this part will become just 1. So it is integral a to b absolute r prime t dt, which is nothing but the length of the curve L. Just L. Where L is the length of the curve C. Here we have to note that f is a scalar function. You will be seeing a similar formula for a vector function, for a vector field f. So this particular formula is for a scalar function. So we are evaluating the line integral for a scalar function. So this is the formula you need to memorize. Now for this problem, c is given to be the right half of the circle. So we have to parameterize that circle, x square plus y square equal to 16. Parameterize the right part of the circle. So parameterizing the circle, we get the radius equal to 4. So x equal to 4 cosine t, y equal to 4 sine t. If you consider the right half of the circle, we notice that it is t runs from negative pi by 2 to pi by 2. So it is t lying between negative pi by 2 to pi by 2. So the interval of integration becomes negative pi by 2 through pi by 2. So now let's apply the formula. So we get integral over c x times y to the power 4 ds equal to integral negative pi by 2 to pi by 2. Substitute for x, which is 4 cosine t. Substitute for y, which is 4 sine of t. The whole thing to the power 4. Then ds, what ds is dx over dt the whole square plus dy over dt the whole square, the whole thing square root. So it is square root of dx by dt the whole square plus dy by dt the whole square dt. So we have to compute dx by dt and dy by dt. So x equal to, in general, or cosine t, in this case radius is 4. So x equal to 4 cosine t, y equal to 4 sine t. So dx by dt would be negative r sine t or negative 4 sine t. dy by dt is 4 cosine of t. So integral negative pi by 2 to pi by 2. The required line integral is negative pi by 2 to pi by 2. 4 to the power 5 cosine of t sine to the power 4t. Then you substitute dx by dt and dy by dt for the radical part. So it is negative r sine t the whole square plus positive r cosine t the whole square. So you can replace r by 4 in this particular case. So it is 4 to the power 5 integral negative pi by 2 to pi by 2 sine to the power 4t times cosine of t square root of, you have 4 square which can be taken out of the integral sign, which is 16 sine square t plus cosine square t dt. The square root of 16 is 4, so that is 4 to the power 6. That is integral negative pi by 2 to pi by 2 sine to the power 4t cosine of t times dt. Cosine square t plus cosine square t equal to 1. Then now here you can apply the u sub method. Substitute sine of t equal to u. So that will give us du equal to cosine of t dt. So you are changing the variable to u. So change the limits as well. When t equal to negative pi by 2, u would be equal to sine of negative pi by 2. This is u. That will be negative 1. Then when for the upper limit pi by 2, it is sine of pi by 2. So u is equal to 1. So changing the limits, 4 to the power 6 integral negative 1 through 1, so u to the power 4 du. So integrating that, we will get 4 to the power 6 u to the power 5 over 5 between the limits negative 1 through 1. Evaluating this definite integral, we get 4 to the power 6 over 5, 1 minus of minus 1, which is equal to 2 over 5 times 4 to the power 6. That is the line integral value for this scalar function x times y to the power 4 over the curve C, where C is the right part of the circle x square plus y square equal to 16. So you can also actually find out this value from your calculator, but this is an okay answer. You are leaving the answer in the exact form, which is fine here. Hope this video helps, and don't forget to watch my next video where we will be discussing the line integral for a scalar function over a different path.